the Boyle's law is just like what we did yesterday, but let's go ahead and do Dalton's law. Dalton's law is you're just going to have whatever your total pressure is. You're going to add your partial pressure plus another partial pressure. However many partial pressures you have, you're going to add them, okay, together. And that's it. So let's look at number 1. What's the first partial pressure they're giving you? So that's my P1. What's my second partial pressure? That's my P2. And so I'm looking for my total pressure, right? So what do I need to do here?
Add them.
Yep, you're going to add them. 736 torr is my first partial pressure. And then 22 torr is my second partial pressure. So this will give me my total pressure in torr. So 736 plus 22, what's my answer there?
758.
758. And that's it. You're just adding all of the pressures together. Now, is it possible for them to give you the total pressure? Get off the phones. Guys, get off the phones. Okay? Give me the 10 minutes and then later on you're not going to have problems, okay? I promise you. Okay, if I give you already a total pressure of, let's say, 896 psi or torr or whatever, bless you. And then later in the problem, I give you a partial pressure of 256 torr. And then I give you a second partial pressure of, let's say, 305 torr. And then I ask you, well, find my third partial pressure. How are you going to do that?
Okay, so what was that?
If my total is 896 torr, and I have a partial pressure of 256 and another partial pressure of 305, how am I going to be able to find my third partial pressure?
You subtract.
Yes. From what?
From the total.
Yep. You're going to subtract the 256 plus the 305 from the total partial pressure, and that'll give you the third pressure, right? Because these three should all add up to your total. Correct?
Okay, so is the blue one still, are we still in problem 1, right?
No, we did problem 1. We already finished it. I was just giving another example.
Oh,
Okay?
okay.
Because in problem 1, they gave you all the partial pressures and they asked for the total, right? But in a different problem, they can give you the total and some of the partial pressures, and then you have to find a third partial pressure or a fourth. We see that? Yes? Do we need another example?
Yes.
Okay, let's do another example.
Number 3.
All right, so now let's go to Charles' law. You're going to forget about this formula. You're going to use this one. Your V1 times T2 equals V2 times T1. Okay? So
this is just another one, right? Like Boyle kind of?
it's kind of like Boyle's, but it's not Boyle's law. You have to,
I understand that.
you're going to be using temperature. So again, you're going to be labeling what you have. So 250 milliliters, what is that?
Volume.
It's volume, so this would be my V1. 25 degrees Celsius, what is that?
Temperature.
And this would be your temperature, and that is your T. Okay, what is volume? That means you're looking for the second volume. 95 degrees Celsius is what? It's temperature, so that's my T2. Now, before we even get started with the problem, what do we have to change? Adrian, unplug. Unplug. What do we have to change? What do we have to do to the temperature?
Oh, the Celsius to Kelvin.
The Celsius to Kelvin. And so you're going to use this formula, okay? So since I have 25 degrees Celsius, can we close the door, please? He's a little too loud. Across the hall and it's
It would be 25 plus 273.
25 plus what?
273.
273, very good. This will give you your Kelvin for the first temperature. So 25 plus 273 is how much? 298K, very good. And so 298K is going to replace your T1, and this is going to be 298K. All right? All right, which other one do we need to do?
95 degrees.
Yep, you're going to do the 95 degrees. Okay, so 95 degrees Celsius. What do we do to that?
Plus 270.
Plus the 273. You see how you're just plugging it in right into that formula? Okay, it's going to be what?
368.
368. So this will change to 368K. All right. Now, do we have everything that we need to do our problem? Yes. Okay, now don't forget we must show our work. So let's go ahead and do it over here on this side. V1 is what? 250 milliliters. Very good. Let's try to squeeze this in. I know I'm low on space. Or you know what? Let's move this a little this way. Okay. All right. So now, what's my T2?
95. 368.
368, because we changed it, whoops. We changed it to Kelvin, remember? Now, I heard a little earlier someone say the 298. Remember, this is the one place where most people make mistakes. It's the T2, not the T1. So I know with Boyle's law, you had V1, P1. Here you don't. You have V1 and T2. So make sure that you're doing the second one right here in this spot. Okay? All right. And then my V2, is that what we're looking for? So that's going to be our variable. We're solving for x. Now, what's my T1?
298.
298K. Very good. Okay. So now we're just solving for x. So what's my next step? Just like yesterday.
Divided by 298.
Yep. Because we want the V2 alone, and that's going to be the answer that we're searching for. We want it by itself, so we're going to divide by the 298K. What you do to one side, you must do to the other side. This allows us to cancel out the Kelvin, and it leaves us with the milliliters, right? So 250 times the 368 equals, divided by the 298, what's my total milliliters? 308.7. I like that, in unison. Very good. That was cool. We're on the same page. Okay. So where do we have questions on this so far? Where do we have questions on this so far? You see how it's just like yesterday, except you're just trading.
Steps gonna be in all the same problems, like those steps.
For the temperature?
Yes.
For the Charles law? Yes. So remember, guys, remember that I had someone ask me yesterday, what if my variable's on the left side, ma'am, and I'm looking for the V1 instead of the V2? You're still solving for x though, right? So remember, whichever one is the lonely one, that number that's with the lonely one is the one that divides. And it doesn't matter if the lonely one's on the right side or on the left side.
What about
Okay.
number 7? It only gives you 2.
Number 7,
Wait, it only gives you 3.
let's look at it. Number 7. I don't have all of number 7. What does it say?
It says helium occupies a volume of 3.8 liters at negative 45 degrees Celsius. What volume will occupy at 45 degrees Celsius?
Okay, so what's your first number?
3.8.
Yep, and that 3.8 is what?
Volume 1.
It's volume 1. What's your second number? Negative 45 degrees Celsius. And what is that? It's T1. What's my second number? That 45 degrees Celsius is my T2. Now don't forget, you need to change these to K, right? And then you can do your formula. Because what are you missing? You're missing the V2. So it's still the same, you're solving for X. Did we see that, Jalen?
You're solving for what?
You're solving for the V2. You're still solving for X. You're solving for one variable. Okay? We see that, Jalen?
Number 1, right?
Huh?
We were solving for volume 2 on number 1, right?
Yes. And it's just a coincidence that number 7 is also you're looking for V2. Okay? Because that's what you're going to be looking for. Are we good? Yes? Okay. All right, guys. I'll go ahead and load this up in case you need it later. Let's just do another example. Okay? If I give you a partial pressure, yes, you can write it on page 59 of your INB notebook. Okay? If I give you, let's say, 250 psi, and that's my total partial pressure, and then I say, well, in a syringe you had a partial pressure of 200 psi, and in the tube you had another pressure of, let's say, 25 psi. What would be my third partial pressure?
25.
Yep, because everything has to add up to the 250. 200 plus 25 gives me 225 psi. I subtract that from the 250 of my total, and it gives me 25 psi left over, and this would be my answer, right? Because all of these three need to add up to my total. Correct?
So T is the temperature, right?
Yes. No. This T is your total pressure. If you have T in the formula like the other formulas I gave you earlier, yeah, Miha, we're on PSI. We're on the pressure right now. Okay, so let's not confuse that because that T is temperature, but we're not there yet. Okay, let's stay on task. Anything else on the partial pressure on Dalton's law? Are we sure? We positive.